Bismillahirrahmanirrahim. Viewers, my today's lesson is continuation of the previous topic, power factor improvement. But today I will emphasize on how inductor behaves with AC power supply. This is the main topic, main point of discussion will be today. So, when AC is applied to an inductor, how does this AC is going to affect this inductor? This is now we know that this is our AC is basically sinusoidal, and it's changing according to the sinusoid. It's increasing and going to the maximum value, then coming to zero, and then going to negative values, maximum, and then coming to zero, and this is the one cycle. And this is continued for, if it supplies 50 hertz, then it means there will be 50 cycles in 1 second. So now let's see how it works. For this I will draw the figure. Okay, let's come to the board. I can explain it. Okay, so let me show you. If this is an AC supply and this is an inductor, this is the current I. As I have explained earlier, that the main function or problem with the inductor is that it does not allow the change. It resists the change in the current. It means when current wants to enter this inductor, this conductor is not going to allow it to enter in it. So definitely current will have to wait for a certain time to enter, or it will slow down, its entry will be slowed down. And we know that current is continuously changing. Let me clear you one thing, that inductor does allow the current, but it does not allow the changing current. Rather, this should be kept in mind. So this current is continuously changing, that it means this inductor is going to resist its entry. So what will happen? The voltage which has to appear at the two terminals of this inductor will be delayed. It will not be appear simultaneously or suddenly, but this current will enter this inductor after lapse of some time. That's why we say that the current lags the voltage. For pure conductor, if this is the voltage and this is the vector for a current, so in this case the current will lag the voltage by 90 degrees. So in the inductor, the current cannot simultaneously change or enter the inductor, but it is delayed by certain time or certain angle, and that angle for pure inductor is 90 degrees. We will have how this will be represented by a means of a graph. Okay, let me show you that this thing will happen. How this thing will happen? Current is trying to enter this current. This is a changing current, and its entry has been delayed by this inductor by 90 degrees. It means the current will pass through it, which will have a resistance rather than say it will resist the entry of the current, and its value will be known by the reactance of the inductance, and that is known as inductive reactance and denoted by XL. So what will be the voltage? Voltage will be L di by dt. L di by dt, negative sign will indicate you that this voltage induced at the coil will be in opposition to the applied voltage. And it does depend upon the rate of change of current. Di by dt is the rate of change of current. So the voltage appeared across the inductor is L di by dt, and L is a constant, which is an inductance constant. Okay, so this is how we can say how the current is not permitted.